Welcome back to the series. We have Kane with us again, who will be discussing UV curing and how our technologies have advanced, making it easier, safer and cheaper to cure a range of different applications. So Kane, what will you be talking to us about today?
Today I'll be discussing curing and how technology is evolving to make it easier, safer and cheaper to cure for a variety of different applications. These are applications where you have a liquid coating that you need to set, for example inks, resins and varnishes. In the past, these kinds of materials would often be cured by drying or evaporation, which has disadvantages that include potentially producing toxic materials. It can risk the shrinkage of the cured material, and also it can just take a long time to cure in the first place. Energy curing solutions such as visible and ultraviolet light and even electrons can be used instead to provide instantaneous curing that can help improve productivity, reduce environmental impact and enhance the performance of the final product.
How exactly does the curing process work?
With conventional drying applications, the material needs to have the moisture removed from the coating. To do this, it is often heated, physically drying the material to the substrate. In doing so, some of the substance is evaporated away, reducing potentially toxic gases that then need to be exhausted away from the area. As an alternative, you can use UV lights to dry the material without these side effects, but this requires special coatings to cure. These coatings, in their simplest terms, consist of a photoinitiator, which reacts to the UV light to begin the curing reaction, and an adhesive, which is the part of the material that hardens and cures. By reacting with the light, the photoinitiator starts a reaction in the adhesive, breaking open the chemical bonds and creating new bonds across the molecules, cross-linking them and strengthening the coating. UV lamps have been the standard for applying this light to industrial applications that require this kind of process in the past, but advances in LED technology have allowed this to become a key technology moving into this decade.
Why use LED rather than lamps?
There are two key points that have kept lamps in the market ahead of LEDs in the past. Firstly, they've been capable of outputting much more power than LEDs, which means that the dose applied to the cured material is greater. This means that the curing process takes place faster, and as a result a higher print speed can be achieved. Another difficulty initially was getting hold of the correct coatings to be cured. A UV LED only outputs light in a very narrow wavelength band, which means that the photoinitiators in the cured material need to react to this very narrow band in order to get a complete cure. These have become more and more available over time. In addition, LEDs in the UV region have historically been quite expensive, putting up a barrier to entry for many. However, this has changed a lot over the last few years, and LED technology can now produce high power outputs as high as 30 watts per centimeter squared and have a wide array of curing materials to choose from. Whilst the initial cost of a UV LED system is still larger than that of a lamp, lifetime of tens of thousands of hours means that over time these become much more cost effective as they require less maintenance and replacement. This means for people looking at continuous industrial applications, there is much less downtime, which means a much more productive and cost effective manufacturing process. In addition to this, LEDs have an environmental advantage, as they can be activated instantaneously with smaller input power, which means they use much less energy to operate. And they are also mercury and ozone free, which reduces the cost of keeping the local environment clear during operation and when disposing and replacing them.
If I want to move towards UV LED, what do I need to do?
UV LEDs for curing applications are usually optimized to one of four wavelengths: 365 nanometers, 385, 395 or 405. So the first thing you will need to do is make sure that you can cure around these wavelengths to get the best out of the technology. From there are a wide variety of options depending on what you're looking to do. For smaller area applications that just require the light to cure a fiber connection or a small glued part during manufacturing, a small spot curing source such as our LCL1 that you can see here would be great, as it is compact, standalone and can be easily operated both manually and automatically. For those looking at larger area curing processes such as printing and varnishing, there are a number of options available. For some applications, depositing one layer of a material, just a single higher power unit will be enough to achieve a full cure. However, for example in industrial printers where you're depositing multiple coloured inks onto one another, you may need to add some extra stages. After each colour is deposited, a lower power UV LED unit pins the ink in place whilst it runs through the rest of the printer, before a large unit at the end performs the final deep cure and finishes the product. There are a number of LED modules available for these kinds of applications that can provide high power, larger doses, or even a mixture of wavelengths, and they can be connected together to accommodate narrow web and wide web applications.
Do I need to redesign my system to convert to LED technology? What if I can't find something that exactly fits my requirements?
Not necessarily. There are LED modules designed to be a similar shape to existing lamp cassettes to ensure that they can be retrofitted into existing machinery without requiring a full redesign. For larger projects, Hamamatsu have the ability to make LED sources unique to our customers' needs to maximize the performance of their applications. So if you see a Hamamatsu UV LED which isn't quite right for your application, we may be able to make the necessary modifications. Please get in touch with your local Hamamatsu office for more information.